Almost exactly 1 year ago, I was so impressed by Cursor that I even started making YouTube videos just to spread the gospel. The autocomplete functionality was nothing I had ever seen before, and also the chat functionality that you could ask questions about your code base simply was so useful that I thought I need to share this with other people. But I think no one except for some Vim fanatics would have thought that in 2025 your terminal actually would become the most powerful coding tool and not some kind of AI IDE, because 2025 really has become the year of the CLI with Cloud Code and GPT Codex almost completely taking over as the most powerful AI coding tools. So it's kind of weird that in the old days we were coding on a terminal, then Steve Jobs brought us the GUI, and now in 2025 we are back to using the terminal. So my outrageous prediction for generative AI in 2026 is that we will go back to using punch cards. So yeah, you better learn how this works or you won't be a 100x engineer in 2026. But anyways, I initially also was very skeptical about Codex, because I thought, why would I want to code in my terminal? And it doesn't even have Markdown. It doesn't look very good. I much rather code in Cursor. But after using it for a while, you quickly get used to it. And you also notice that this is a completely different way of coding, and it's much more similar to having like 5 junior coding employees at your service than something like Cursor. It's really an entirely different way of coding, and that's also why it does have some kind of learning curve. So that's also what I want to show you in this video. Like, I want to teach you everything I know about GPT Codex CLI and how you can best use it, so you can go from Luffy in episode 4 of One Piece to Luffy Gear 5 very quickly with just watching this one video. So let's first think a bit about the Codex CLI mindset, what you need to have in your head when you're using this tool, because it's quite different than if you're used to Cursor. I would say Cursor is more akin to being put in a very fast car, so it speeds you up a lot, but you're still the one driving and actually working very closely with the AI to get it to do what you want. While with Codex CLI, it's more like instead of the AI living in your code editor, you let it run loose on your PC, so it can really do things completely independent for you. And you also, if you want to make it as useful as possible, you should have many of these agents running in parallel, and your job will just be to check on them when they are done with working, review their code, which is also very important. But in general, it's more like you're monitoring all of these agents working independently. And I think it's much closer to being some kind of air traffic controller, or like it feels like you're often like, if you would play chess against multiple opponents simultaneously, you constantly need to switch context between what each agent is doing and very quickly thinking about, okay, what needs to happen next, or was what this agent did all right? And that is quite different than just using Cursor, but because with Cursor everything is like directly instructed by you. You're only working on one thing at the same time, and it's a completely different way of coding. So what I often do with Codex CLI is like I'm building an app. For example, at the moment I'm building an investment app, and what I do is I have 2 terminals open that work on my front end. I have 2 open that work on the coordination between front end and back end. For example, if the front end needs some kind of API method that the back end doesn't offer, the coordination agents can do that. And I also have like 2 agents working on my back end. I will show you later how I exactly set this up such that these don't interfere and you can still be up to date with what every agent is doing, but that's for later. But that doesn't mean that you have these autonomous agents running and that you can just sit back, put a cigar in your mouth and just do nothing anymore. No, it's not like that at all. It's more like a traffic controller in that you really need to check on these agents all the time, because they finish their tasks in 3 to 5 minutes and you're running multiple in parallel. So every time you're really reviewing the code of one agent, giving it another task, and then waiting, and by the time you're done with that, another agent has completed this task, so you need to check on that. So it's not less intense than just manually coding, or it's just a different way of coding. Also, these agents often make mistakes. These are not perfect, and in that case it's also much harder to debug, because of course you haven't written the code yourself. And I think especially if you're newer to coding, you will notice that it's much harder to look at someone else's code and understand what it's doing compared to when you have written the code yourself. So I often, like a few days ago, I spent like 2 hours debugging something an agent has done, but because still, even with spending this time debugging, the project will still be done much faster, because I can work on it in parallel, and actually implementing the feature would have taken me, for example, 5 hours. So if it is done in 10 minutes with Codex CLI and I spent 2 hours debugging, I still have 3 hours of time. So it's in that perspective you have to think about it. You're constantly going really fast, and then you often get stuck, need to debug for a while, and then you go really fast again. And doing that in parallel, like 5 features at a time, that's the way you should think about coding agents. And I also gotta say, like, don't throw cursor away, because like I said, debugging gets much harder, and having some kind of IDE with AI-powered functionality can make debugging much more easier, as I often just ask my favorite LLM, how do things work? And because you're only working on one feature when you're debugging, of course, then these AI IDEs still become very useful, and they are a really good tool for debugging, because as I said, the debugging will get way more complex. So any AI assistance in that is often very helpful. So yeah, another thing to think about it is like, how do I get speedups from this? Well, it's mainly, it's not like you send off an agent to do a task and then do nothing. No, you should immediately send off another agent and do something, or do something else in parallel yourself. You should try to keep juggling as much agents as possible, because as much parallelization you can do, the more gains you get. And this is quite a challenge to manage all of this, of course. Another thing to keep in mind is these agents like Codex and Cloud Code are not AGI yet. They can't solve every coding task, like Carpet even said in an interview that when he was working on his, I think it was GPT Mini or Nano library, that the AI would keep suggesting wrong code, because for cutting edge things, there of course isn't enough training data that the AI has seen yet. So if you're working on really new things, then AI is probably not going to help you. But I think the majority of things that we want to do or build, that there is of course enough training data about that, because the majority of things that we do are often just like using some kind of Supabase or Postgres database, creating a Next.js front end, making a Stripe integration. Like on most things, these AIs have seen enough training data, but of course you can't expect them to be AGI and implement the next PyTorch for you. So always keep that in mind. You should really be able to ask yourself, is this some kind of task for which the agent could have seen training data? And if not, you still have to manually code it yourself. It's also important to know, like, if you're using these coding agents, you should really, if you want to use them to their maximum, you really need to be able to plan ahead very well. You need to know what to build. You can't just ask Codex CLI, go build a game or go build an app. No, you need to plan exactly what needs to be built. You need to chunk it in small enough features such that it can be finished in the 5 to 10 minutes that Codex CLI runs. And you also need afterwards to, of course, to debug it. And this is also why I think like using these tools to their maximum potential is very hard for people who are new to coding, because I think especially like planning, knowing the entire architecture of your project and also debugging and reading other people's code is not very developed if you're new to coding. So yeah, you should be in the mindset of an architect when using Codex. So I hope you haven't fallen asleep yet by my mindset explanation. We will now start with the actual practical part. Okay, so I would say the first thing you really need to install and start using is Git. And I think if you're a software engineer, you're already using this, but you're really letting an AI agent go loose on your PC, or at least restricted to certain folders. But you also want to be able to revert your folder to their previous state, because if Codex CLI changes a file, yeah, you of course want, and it's not very good, you want to go back to the previous version, and it can often take a few commits or changes until you notice something. So version control is essential, and yeah, just install it if you don't have it. You should really be used to like common features like git add, git commit, git push, git stash, git branch. I'm not going to give a Git tutorial, and I assume you already know this, but if you don't know it, just search for some YouTube videos or ask ChatGPT to explain you the basic things, or ask Codex CLI himself how it works. The next thing you need is Codex CLI, of course. Just go to the OpenAI website and install it with your favorite installer. I often like to install every one of my packages with Homebrew. And to install Homebrew, of course, go to Homebrew, which is a package manager for macOS. So just copy it. And let's go to my terminal. So you can see that which Codex. You can see I've already installed it with Homebrew. To be able to work with this, you need a ChatGPT subscription, either ChatGPT Plus or I think it's called ChatGPT Pro. You can also link your own API key if you want, but I really wouldn't do this because these often cost, like in one session you often go through hundreds of thousands tokens per per 30 minutes or so. So you will so if you, especially if you're going to use these in parallel, as I expect you would, you will pay way much more by using the by using your API key than you would by just buying a $20 ChatGPT subscription. But yeah, you do you. Okay, so what we're now going to do is we're going to create a new folder, Codex CLI test, go in it. Of course, you don't have to do this all with the CLI, but let's now look a bit at how Codex works. To launch Codex, if you installed it, just go to the root folder in which you want to initialize Codex, which for now is going to be our project. But later I will show you in a setup where you actually initialize it into root of multiple projects, so it can work on multiple or see multiple in parallel. But at the moment, just go to my Codex CLI, initialize Codex, and the first thing it is going to tell you is that this folder is not version controlled, so we haven't initialized Git in it. So it's going to recommend us that for every file that Codex wants to modify, delete, or any command like git or web request it wants to execute, that we need to give it manual approval, because of course this is the safest way of operating, especially if you can't go back to the previous state. But you can also give it permission to do all of that without permission in this folder. But this is maybe a good opportunity to go about the sandboxing and security modes of Codex, because if you go to this Codex security guide, you will learn a bit more about the sandboxing and approval modes. And as you can see, like version controlled, non-version controlled folders are read only, and version control folders will allow Codex to automatically read and write to every file in that folder, but for some commands it wants to do, it will ask for an approval request. And there are multiple things you can set up. You can set up a certain setting for sandbox. So, and you can set up a certain value for when Codex is going to ask you for approval. Let's maybe go over the sandbox options. So sandbox mode. So the values you can set up are read only. That's if you don't ever want Codex to manually automatically adjust or edit any file. You can set it up workspace write, which is what I would recommend. And in this case, in every folder and subfolder, it can do edits. So if you initialize it into root of a project, it will be able to work on your project, but it can't modify other files on your PC, which is a very good trade-off, because you probably don't want Codex to mess with your system files to fix some kind of test. And you can also give it danger full access, and in this mode it can just modify any file on your PC, and it can even cause Codex to modify system files and will cause your PC to crash. So this one, danger full access, I would say just only do this if you are using dev containers, and dev containers is maybe a bit of an advanced, I can't type anymore. Dev containers is a bit of a more advanced concept, but in this way you're basically developing in a kind of Docker image, which is a replica of your setup in which you want to run your eventual code. And of course, if you're developing with these dev containers in some kind of Docker image, which is not your actual system, then you can let Codex run loose. And this is also something which I would eventually can become very useful, but you should of course realize that Docker images can take like 4 gigabytes of your RAM of your PC, so you can't run like 20 of these in parallel. But I think as computers will become more and more powerful, and you can run more of these in parallel, I definitely think that having each agent work in a separate image in which it can fully run loose is something that will be used more and more in the future. So if you already want to get started with it, definitely look into dev containers. But anyways, for now, I think you should just set it to workspace write, which is also the default value, which I think is here with the auto preset. So you can see workspace write. And then you also have this ask for approval option, and this is a bit more vague, I would say, because you will soon see that ask for approval, or approval policy is it called, that when I will run Codex, sometimes it will ask, can I run this command? And then you have to manually put yes or no or always. By default, it will ask you for some things, like I think the default is untrusted. So if it isn't, this is often a bit weird to me. Like I don't really often see the difference between untrusted and on request. I think certain commands are by default set as untrusted by your OS. For example, things like network request or some kind of git commands, and you always have to approve these. And then you also have on failure. So if Codex tries to execute a command, but your OS security, so macOS says, oh, you don't have permission for that, then it will ask for approval. And I think on request is just if Codex CLI thinks it should ask for approval, then it asks for approval, and never is that it will just, if it encounters a command that the macOS security or your Linux security or Windows security says like, oh, you can't execute it with your sandbox setting, then it will just not ask for permission and not do anything at all. So if you want to go fully autonomous, you just go here with the dangerous full access option, and that's just bypass all approvals and work on any folder, but that's not something I would recommend. So we are actually going to go back, so cancel all of this, and the first thing I'm going to do is init a Git folder, so it's completely tracked, and initialize Codex. Let's update. Okay, let's restart Codex. And it says since this folder is now version controlled, you can go into auto mode, and this will just give Codex permission to edit any file in this folder and subfolders. So let's just do that. And now we are in the main Codex screen. From here on, you can just ask Codex to do anything in this folder from the subfolder, like implement X feature, or what does the code base do, or just like anything you would ask ChatGPT, and will go work on that directory that is set here. Codex also offers these slash commands, which start with a slash. So these are basically things like you can modify which model you should use. I would just recommend using the default model, because it's often the best. Like Codex Mini can be good to save some tokens, because you will have some rate limits, but it will automatically switch to it once you hit 90% of your rate limit. So I wouldn't do it by default, and just Codex Max is at the moment the best model, so just use that. You can also modify what kind of approval, so sandbox mode you do. So like I said, I'm not going to give it full access. I'm just going to go with the default option. You also have a review slash command, and I will show this later, but this is very useful to after Codex has coded something, you can review the changes it did, and you can even like compare against a Git branch. At the moment I don't have any branch, so I can't do it, but you can review a specific commit, search for it. This is very nice to do. Then you also have new, which new basically, you see here I have 100% context left, and this is like these the context window of your LLM that's getting filled over time. But sometimes the context is just not good enough, or you see Codex is going into loops, and with the new command you can basically start a new conversation and start at 100% once again. So that's also very useful to do, because else you would just, like I did, just have to quit Codex and restart it again. But with the new command you can just do that as well, and it will create an agents.markdown file. So at the moment I will run this. It will just, agents.markdown file will contain important instructions for the agent itself, and this is a very powerful tool to control how the agent will work. It's like the readme.markdown file, but then for agents, and it will basically respect any rules you set in it. As you can see, with the init method, it will give Codex automatically the task to create an agents.markdown file. But of course, there is almost nothing in my repo, and there is nothing in this repo, and I also didn't give it any instructions, so I'm wondering what it comes up with. Created an agents.markdown file. So you see an agents.markdown file has been created. It gave itself some instructions. But to be honest, I don't find this init method very useful, because I will later show you how we can better create this agents.markdown file for yourself. What else can we do? Like Codex slash review will summarize the conversation, and then so you can free up some context space. Undo will undo a turn of Codex, so it goes back to its previous turn. I don't know why Codex also offers a git diff command, because you can also just do that with the git CLI. You can mention a file by typing mention, and then, for example, at the moment I only have this this agents.markdown, and you can then refer to it for Codex, but you can also just type auth and then agents.markdown or any file you want. So I often just use the auth. Then you also have this status, which will show you how your rate limits. It will also show you your setting, which you can return to, which plan you have, how you have a 5-hour token limit and a weekly token limit. This very often resets. I think it's just the start of the new week, so I still have 100%. You can often code for I would say a week, for a few hours or more a day on the plus plan, so that's good enough. What also should I tell you? MCP. This can be important. I will go over it later, but you can see which MCP tools you've added. You can give feedback, exit, and quit. So, enough about the git commands. However, I think it's also important to set up a good config. Instead of doing all your settings in this with the / commands, there's also a config file that's even a bit more advanced. I'm not going to through all of this. You can set up specific profiles, for example, certain feature flags, but there is 2 important things that I would recommend you to set up. So let's go to open it. So you see how my config looks like. You can set up a default model, but I just used the recommended one. You can set up a reasoning effort. I think the values are reasoning effort. You can set up low, medium, or high, but I would just set it up for medium because you don't want to waste too much tokens. Some interesting command is, for example, this notify command, and what this does is it allows you to invoke a script every time that Codex CLI has completely finished its turn. And what I basically did is I made some kind of macOS notification tool, so that each time that Codex finishes its turn, I get a macOS notification. I will show you a video of this because when I'm recording with OBS, these macOS notifications don't appear. If you want to install this yourself, go to GitHub, GitHub repos, and puff, and I made it for Bender, and you can just install it with brew once again, and set it up like this in the notify command, and this will basically give you a macOS notification if your agent has finished, so you can work on something else, and when you hear this notification, you know, okay, the task is done. Okay, you see the trust level of all your repos. And then under features, I would also turn web search request on, because this will allow you to Codex to use a browser tool. So it can, for example, search for documentation online, or do anything other online. And this is very useful. I also created a profile just to test things out, and then you can just do Codex profile and set up this profile if you for some reason want to use something other than the default, and these notices are something set up by Codex CLI by default. Okay, so let's get started with building our own project in the Codex CLI test, and what we are going to do is we're going to build this browser game inspired by the Google Chrome Dino run game. Let's see, I basically want to build something like this because I've never actually tried this before this tutorial, but I think this should be doable with Codex CLI and show you how it works. So the first thing we of course are going to set up is this agents.markdown, because this is some kind of rules and prompt for the agent which it needs to follow, and is a very good way to control it. So let's look at an agent markdown file of another project I'm doing, some investment app, and let's show you what's inside it. I basically describe the project a bit, then I set up some rules, for example, that for all the frameworks I'm using, for example, for Next.js, you can use client and server components, but I say like, don't ever use server components. I say always write tests that can be executed with the CI tool. For styling, use Tailwind CSS. Avoid global installations, don't do this, don't write backend code. After creating a new feature, do this, and README, do this. So of course you can't copy and paste this from some kind of other project. It's really dependent on what you want to do with your project and how you want to build it. And I often start with a very basic README or agents markdown file, and after a while you start noticing that, oh no, Codex is doing this and I don't want it, and then you add it to the agents.markdown file, and then you build this iteratively. So let's start what we want to do for our thing. How I'm going to call it, Chrome Dino game run clone. I'm going to describe it a bit. This is I'm going to build a Next.js. This is a Next.js project that is a game like the Dino run from the Chrome browser. I'm going to set up some rules. So let's type rules. Rules Next.js, use only Next.js client components, like to keep it simple. Tailwind CSS, use Tailwind CSS for styling. What I'm also going to tell it is, and that's also important, that you explicitly often say write tests for every feature you write, because like always, like it's also important for general software engineering, but especially for agents, it's important that they can automatically run a test and see if their code works, and then afterwards they can take this input to fix the feature. And that's also why you want some kind of some kind of pre-commit hooks. And with if you don't know pre-commit, it's something like if you type git commit, it will first run these hooks, and these can be things like a formatter, a linter, your test suite, and this way you know that your code is actually in a good state before pushing it to your Git repo. So I'm also going to tell it like CI, use Husky for pre-commit hooks. And if you don't know Husky, no, not the dog, JavaScript. It's a pre-commit hook, like I said, but it works for JavaScript. And if you're working in any other framework like Python, I would just use pre-commit. I'm not going to explain all of this, but you should look into Husky or pre-commit depending on the project. Okay, and I'm just going to copy these commands for my other project. That after every feature that it should run git add and Husky pre-commit. And our agents.markdown file now looks like this, which is enough to begin with. You can of course use Codex right in the CLI terminal of your editor, but this is not very scalable, I think, and especially if you run with multiple agents in total. I find it much more useful to just open a terminal window separately, and that also puts you into the mindset of using a separate, really having like a separate colleague available that's not involved with the IDE at all. Okay, so let's get started. The first thing, of course, is we need to install Next.js. So I'm just going to give it a task like install Next.js. you don't want to give it too much. I could also say like also install Husky, but yeah, the better you break up these features in small tasks, the better the better the results will be. You will see it will start executing some terminal commands, and even with the auto mode, like network requests aren't permitted by default. But the thing is, like, and that's also important, it wants to install Next, React, and React DOM. But I've already once installed just create Next app, and this is much easier. So I'm just going to say no, don't execute it, and tell what to do differently. You can also already execute because I've already installed that one, and there's a much better way of installing in the Next.js project. It will ask for permission. I say okay, proceed. And that's also why you really need to often think about what it's doing, and it's important that it asks approval for certain things, because you don't want to let it run completely wild and it will just start making a mess of your project and all your installs. I think it has created some files like a default Next.js project, but I can see it's initialized it not in the root folder, but it installed it not in the Codex CLI folder, but it created a separate folder for my app. So I'm going to say that it needs to be moved to the root folder. Root folder should be let's see what it's going to do now. It's going to remove everything. Okay, you can do that. You don't need, what is it trying to do? Temp app, yes, no. I don't know why it was going to create a stamp app, because an agent.markdown is present. Okay, that could be, I don't know if that's really the case. Just delete the agents.markdown and put it back later. Remember the contents though. Let's see if this works. So now let's install this. Okay, Next.js with Tailwind is scaffolded. It also gives some things to set up next, and it also says because I didn't set up Husky yet and it sees this in the agents.markdown, it will recommend it to do that. Okay, just run the npm install. You can also do these things yourself, like npm install, but just for showing you the how Codex CLI works, I'm just going to let Codex CLI do everything. Npm install. You can also just, instead of just clicking yes, you can say yes and don't ask again for this command, which can be useful. For example, it can always run npm install for me, so I'm just going to do auth. Dependencies are set up. Okay, sounds good. Let's see if it indeed worked. npm run dev, turbo pack. Let's see, and this is indeed the Next.js starting templates commit. And I'm just going to give it this pre-commit file for my other project, so it knows what kind of things I expect. I expect lint stage, lint, and test. Okay, now set up Husky. I want the following hooks in the Husky file. Dev dependencies, it asks to install Husky and lint staged. Okay, you can install it as dev dependency. You can see it often tries to do things like adding things to my git config, which is necessary for Husky, but the macOS, my sandbox environment doesn't allow this, so I need to allow it manually. Okay, so it came back to me. It says it set it up, so let's see if it indeed worked. So let's do a git commit. Okay, you can see it's run all the tests. See test files, test passed. What did it set up for Husky? Pre-commit, lint staged, npm run lint, and npm run test. Okay, so for the next part, we are going to start building, and let's just clear the context, because all this setup, it shouldn't have that in the context when doing the next feature. And I'm going to describe my project to Codex CLI and just ask his opinion about how we would set this up. And because it's very important that before you start implementing, you start planning a bit with Codex. So let's describe. I want to build a Chrome, a Dino run clone like Chrome. No internet. It should be very simple. For a demo, how would you approach this? So don't ask it to implement something, just ask him for his general opinion. And it says we can keep this lean. I'm just going to ask what do you think would be a good first feature to implement? It says like a client page showing the Dino ground line. Okay, and I'm just going to say, okay, get started. Okay, so I think I see that it tries to do git add a lot, but I see it hasn't got a permission for that. So sometimes it also fails to ask you for permission, so you can just interrupt it by pressing the escape and just, I see that git add is failing, just ask me for permission. And it will ask for permission. I will say go ahead. Okay, so it added some files, and here is where the VS Code also comes in, is that you can easily review what has been added. You should get really used to this, really review all the components that have been added or what has been changed. If you don't understand something, let's see where I can, for example, do this like, you can ask like, is this necessary? I often like to use the ask mode of cursor for this. If you don't understand something, and it will give you why it's not or why it isn't. I'm not going to review all of this code for this simple tutorial. So what I'm going to do is just go npm run dev and run. Okay, apparently already implemented a lot, so start run. Okay, start run isn't working yet. I think it just set up a scene. Plan for the next step to make it moving. Okay, implementing the game loop seems very good. Okay, let's go ahead and implement a basic game loop. You can see it always makes a plan what it needs to do to execute your feature. It will implement it and then write tests like I instructed it and run the git add and then husky pre-commit, so all the tests also run. Okay, it was stuck for a while, but eventually it succeeded in running the tests. It's now going to run the git add husky pre-commit, updating plan, it's run the tests, implemented the first moving version of the Dino game. Okay, let's see for myself. Once again, always check what is added, inspect why a certain thing was necessary or not. Let's run npm run dev. Okay, the jumping doesn't work very well. Like I can't, oh, should I hold it? Okay, I'm just going to tell it, I'm going to ask like the jumping doesn't really work correctly. It keeps getting stuck and I don't jump high enough to get over the first obstacle. Okay, it says it adjusted the jump physics, so let's see. But still, the jumping works kind of like if I jump on the correct, okay, no, it's just very buggy. I can kind of go through it, but it doesn't clearly indicate. I think there is something going wrong with either the rendering, jumping high over the ground. Okay, it is refined, let's see. Okay, maar now he doesn't jump very high anymore. Okay, normally it should work now. And indeed, this is very close to the Dino game. Do these obstacles, there is some kind of high score game, and you can see how you can improve this by giving Cloud some more, or giving Codex CLI screenshots of Dinos you want to make it more visually beautiful. So after implementing a lot of features, what I often like to do is like a lot of code, for example, has been written. You will see here that there's also some errors I see, so we haven't really looked at it, but it's written every component in a very big game file, for example. And this is like, after a while, if you're used to software engineering, you want to refactor things, for example. So what I then often like to do is, first off, let's see, is the game getting a bit too complex? Can we refactor the game when the exec's in multiple? Yeah, I can explicitly mention it with the odds game TXS into multiple components. Let's see, let's first ask for his opinion. Maybe he has a good reason for why this game TSX file needs to be that big. Okay, this time he doesn't seem intended to give me any reason. He will just go ahead with the refactor. And actually, let's say I didn't want him. I first wanted him to do like, to give me a plan, but he has already made some changes. So what I can then easily do, of course, because I committed everything, is do git restore and instantly get back to the to the previous state, and then say first, give me a refactor plan before you start implementing, come back to me with it, or discuss if refactor isn't necessary, because I don't want to make him going ahead. Keep game as the orchestrator, but extract all UI helpers in these components. Okay, scoreboard component seems like a good component. Game viewport seems like a good component. Control button, so go. Okay, sounds good. Go ahead with this refactor. So you see, you can just autonomically set them off and make him do things. You often have to really think about, what is my agent doing? Is this all right? Is he really building a good project? Should I refactor it a bit? Ask him why, what's his opinion on how to refactor it, then make him implement. So there is still a lot of interaction between you and the agent itself. It's not like some kind of autopilot. So it composed it in multiple separate components. Let's see. Okay, this also already seems much better, like the game file is much smaller. Let's see if it also still works, which is of course important, because all the tests succeeding maybe isn't good enough of a test. So let's see, and it's exactly the same game. So that's excellent. So what can now also be useful if you've implemented a lot of changes is to do like a review with the /review command. I don't have a base branch. I will just say like review a commit, and then just last commit. Let's see if it's really good. Okay, he has done with this review. He says everything is all right. So this is basically it for this simple test. But of course, like I said, this workflow of working on one feature at a time, and it's not the way that a really advanced Codex user would use it. So for example, not that I'm considering myself very advanced, but what I like to do is for example, at the moment, working on this, let's see, where is it? On this investment app. And I have both a Supabase backend and a Next.js frontend. And I want to work on all of this in parallel and see all the things that are happening. So what I do is I create a root folder of both my backend and frontend, or maybe there are some other services that are included with your application, and just open my cursor at the root folder. So if there are changes in one of the files, for example, if one of the files changes, that easily shows up in my source control at the root file, so I can clearly see which of the files the agent actually is modifying. Okay, and of course, then the really obvious parallelization is that you create that you put one agent in the front end. So you initialize Codex in the front end, and you initialize Codex in the back end, and you ask Codex implement this front end feature and implement this back end feature. And let me ask something. What is the next feature to implement? Okay. And in this way, you can basically easily work on two different projects at the same time. And when it's done, I get a notification and I come back to it. And I can also easily monitor the changes that are made with this source control panel. And just working on two different projects in parallel is still basic parallelization, because what you can also do is get worktrees. And like if you're used to some kind of Git workflow, you work on a feature in a separate branch, and after you're done, you merge this branch into the main branch. But of course, if you just do something like git branch and then git switch to that branch, the folder, all the files change to that specific branch. But what you can also do, and this is very useful for parallelization, is actually create a work tree. And what this does is it checks out your branch in a separate folder while keeping the original folder on the original branch. So let's say for my backend, I also want to have a good pricing system. So I'm just going to add a new folder called backend pricing system. And create a new branch for that, which is called feature pricing system. And what you can see is I created a new folder right here, and this is just my investment app backend, if I can see, is still on the main branch, while the other folder is on that new feature branch. And by doing this and creating many work trees, for example, I also often have one for my for my front end, let's call it test branch, I don't know, feature test, and then I also have one for my front end. And what I then do is I check out I go with my terminal in each of these folders, initialize Codex in each of them, work on as much branches as I can. Afterwards, if you're done working on your feature branch, you just do git merge and do it, but I don't have any changes yet. Then you do git work tree remove, let's see, backend pricing system. So the work tree is removed from here, and then you just do git a branch delete if you merged it, and you don't have the branch anymore. And this is basically how I work. I try to create as much features that have independently as possible, work on them on their separate branch, merge it into main, delete them, and then I have like 5 or as much agents as I can juggle working on it in parallel. And that's also where you can see some really insane speedups if you can manage this well. And this is something like I can't teach you this, you just need to work a lot with it and you will get better at it. Another cool thing I want to show you is of course MCP. I do think this is a bit overrated. I think it's very overrated actually, at least at the moment, because first off, many of the tools that MCP offers are also offered just in your CLI. I don't think there are a lot of things that you can't access over the CLI, so it doesn't really make sense to add another tool to it because the CLI is so powerful. But something that I did find very useful, and also it's very easy to add MCP tools with Codex CLI. So you can, for example, Figma. I don't use Figma, but it can be useful. But what I want to show you is Playwright. And Playwright is an MCP server that lets your Codex control your browser. So it also has some install instructions right here. So the only thing we need to do is copy this, go to my terminal, say Codex add. So now a MCP server, okay, it says booting MCP server. Okay, so you can see it got some additional tools like browser click, browser close, navigate, etc. So what I want to show you is, I don't know if this is going to work, and I want actually to try if Codex can indeed play my browser, the game it coded itself, so the Dino runner. So I'm just going to open Codex and say, I want you to try to get a high score in the game. First, start the Next.js server, then open the browser to go to the correct page and start playing. I don't know if it has a space bar or something like that, but if it has a space bar tool, I mean, so let's see what it does. Okay, it says play, write, navigate, so it completely opened the browser by itself. Let's see what it wants to do. It sure has to analyze a lot before it tries to play. It's going to say, don't analyze too much, just play. I don't even, okay, it started the game, but it failed. Of course, it isn't fast enough to react, but you can see it tries to play. And I think this will mainly be useful if you are developing a real website, not a game. So what I'm also going to show you, I'm just going to tell it use playwright to use my browser, search for a nice Apple Watch on Amazon.com. Okay, you can see it opens Amazon. It sees my page. It's going to search. And I think this is a bit underexplored at the moment. Like, Codex isn't just a coding agent. It's trained for coding, but it can basically do everything on your PC, like even browsing the web. And I think the possibilities with this aren't explored too much at the moment, and it's really like you can make this shop for you, use your browser, order food, basically everything you want. I've also not tried it out myself that much, but it can be nice to know that it exists. And I think some other advanced uses are, there is even an entire Codex SDK library and TypeScript, so you can really just write scripts to invoke Codex with. And you can also run Codex in headless mode. In this case, it doesn't wait for it isn't constantly reading your standard input, but you can just, if you do Codex exec fix the CI failure, it will just do that. And with this way, you can also integrate it in your CI/CD setup if you would want to do that. So I think I've showed you almost anything you need to know to get started with Codex. I really at the moment believe like this is going to be very important in the future, that you are able to use these tools. And it's also not like you are instantly productive with it. The first times I was using it, I was constantly thinking like, I can do this much faster if I just use a cursor or code it myself. But you should really explore running these agents in parallel. And it's also, I think, if you're a new developer, kind of hard because you have to review a lot of code. You have to instinctively know when it's time to refactor or what it's not doing very well and ask it to do that, because it's easy to build a whole lot of unnecessary things and bloated things, and your code base can easily explode, which causes the Codex CLI not to work very well. Anyways, I hope you enjoyed this video. If you liked it, make sure to subscribe. I'm going to upload a video probably pretty soon in which I'm using Codex to build a full-blown investment tracking app. So if you're interested in that, make sure to subscribe, and I see you in the next one.